Hey everybody, and welcome to the Advent of Code 2020. In order to help you get started, I am going to solve the first problem. I'm not going to read the whole thing because you can do that yourself at adventofcode.com. But basically, you're given this list of numbers, and you need to find the pair of them that sum to 2020. And so basically they give you this example of 6 numbers, and then you need to go through them and figure out which two, when you add them together, add up to 2020. When you find them, you need to multiply them together, and that is your answer that you submit into the website. So this website doesn't have any IDE or coding or anything. It doesn't care what language you use. You can use Minecraft if you want. If you can figure out how to get the two numbers, then you multiply them together and type the answer into the box, and it will tell you whether you're right or not. So I'm not logged into this one because I've already solved it. So this doesn't have that option, but we're just going to solve it for the example case here. So the first thing I'm going to do is go over to Replit. I'm going to create a new REPL. It's going to be in Python, and I'm going to call it Advent of Code 2020 Day 1. All right, and I'm going to need a file to hold the data in it, because when you solve the real problem, it's hundreds of lines long, so you can't just copy and paste it in. You actually need to read in a file. So I'm going to add a file called day1.txt, and I'm going to copy that in there like that. Okay, so here's my list of 6 numbers, and I have to go through them somehow to find out which ones sum up to 2020. There's lots of different ways you can do this. I'm going to use the brute force method because I think it's the simplest way. And the brute force method, in my mind, what I'm thinking right now is, well, for each number in this list, I'm going to try adding all the others and see if it comes out to 2020. So I'm going to start at 1, the first one. Then I'm going to add 979, see if that adds 22, 366, 299, so on and so on. If none of those work, then I'll start with 979. I don't need to check the first one again because I've already done those two. So I can just start with 366, 299, 675, and so on. And then if that doesn't work, I'll try this one. If that doesn't work, I'll try this one. If that doesn't work, I'll try this one. And if that doesn't work, then there's no solution. All right. So in order to open that file, I'm going to say with open day01.txt as f. So what that's doing is it's opening this file for reading, and it's using a file pointer here, f, which kind of gives us a list of all the lines in the file. It's really handy. And by saying with, if there's an error, then I can handle that. And it will automatically close it at the end of this block. So that's kind of the best way to open a text file. And just to make sure I'm doing it right, I'm going to say for line in f. So for each line in that file, I'm going to print the line and see that I make sure I did it right. So there you go. It prints them all out, which is exactly what I want. But what I really want to do is I want to have a list. So there's a couple different ways to do that. I can just make it into a list, or just to be super clear, I'm going to say I'm going to make a list, and for each line I'm going to append. And I want to make sure that these come in as integers, not as text. So I want to say int line. Okay, so now if I print out my num list, all right, at the end, you can see I made a list of integers there. I know they're not text because they're not in quotation marks. So what I need to do now is go through these lists and check to see if it adds up to 2020. So I'm going to say for first num in list, right? And for second num in list, oh, sorry, num list. If first num plus second num equals 2020, then, I can just say print first num times second num. Okay. Oops, forgot the parentheses. Okay. All right, so let's see if it works. It works. We got the right answer, but we got it twice. That's interesting. So you can see that here in the example, it says it should be 514579. But I don't think it should be twice. What is happening here? Well, let's look at our algorithm. We go through the num list with the first num, and then we go through the num list with the second num, and we see if they add up to 220. When we first started talking about the algorithm, we said the second number should start at 979. We don't want to check 1721 against itself, because what if it were 1010? We would add it to itself, and it would think that it found two numbers that added up to 2020, right? If it happened to be 1010. So we don't want to check this against itself. And the other thing is, so the numbers that it found were 1721 and 299. So it found this one and this one. But what was happening is the first number was going through here, and every time the first number switched, it would start over with second number going through the whole list. So we went through the whole list with the first number, and for each one we went through the whole list again. It seems really inefficient. So we found our answer when the first number was 1721 and the second was 299, but we also found the answer when the first number was 299 and the second number started at 721 going through the list. So yeah, we got the right answer, but I'm not quite so sure this is the algorithm we want to use. I think what we really need is some sort of counter to keep track of where we are, to start the second number one after where the first one is starting. So we don't start the second number from the beginning of the list every time, because we've already, like we said, we've already done that. So I'm going to change these for loops to be a counter going through the range of the length of the list, right? So what that does is it's going to start at 0, the range from 0 to the length of num list. So in this case, the number of items in the list is 6. So it'll say 0, 1, 2, 3, 4, 5, and it'll stop at 6. So that's exactly what we want. And then for the second one, right, we might be tempted to start our counter at 0 again and do the same thing, but we don't want to start at 0. We want to start at I plus 1. Right? So we want to, I is going to go through the whole list, and j is going to start at the next one after I. So if I is 0, we want j to start at 1. But now that I'm thinking about it, if I goes through the whole list and we get to the 6th line here, which will be position 5, because we always start at 0, how is j going to start at I plus 1? That would be off the end of the list here, so that would be a bad thing. So we actually only want I, our first number counter, to go 0, 1, 2, 3, 4, and j to start at I plus 1. So it's going to start at the next one. So the first time through, I is going to start at 0, j is going to start at 1, and then j2, j3, j4, j5. And then when I moves to the next one, j will start at this one and go to the end. When I starts at this one, j will start at this one, and so on and so on. But I will only go this high, and j will start here, and then both of the loops will be done. So we want I to stop, not at the last element, but the one before the last element. All right, so now we don't have a first num anymore. What we have is we have numList at position I plus numList at position j. And if those equal 2020, then we're gonna print multiply them together. All right. Let's try it now. Hey, so that time it only found it once. So this algorithm isn't 100% efficient because it keeps going after it's done. There are various ways we could address that by exiting the program. This should probably actually be put in a function, and you pass in the sum that you're trying to get to, and then you just return the value you're looking for. So there's lots of things we could do to make it a little prettier, but this works, right? This gets us our two numbers that add up to 2020. So that solves the problem, but there is a better way of doing it, potentially. So if you're interested in sort of algorithm trade-offs, I want you to think about this. What if all of these numbers were sorted? Would that make it easier or harder to find the sum to 2020? Let's do an example, right? So I'm just going to add some numbers down here. Let's say we have 1, 3, 4, 7, 9, or let's say 12. Okay? And so I'm trying to find numbers that add up to, I don't know, let's say numbers that add up to 13. Okay, so if I'm looking through here and I know there's only two numbers that add up to 13, there's no number here that I can add to 3. There's no number here that I can add to 1. I can add 9 and 4 and get 13. There's no number I can add to 7 and get 13. There's no 0, right? So what I can do is I can look at the smallest number and the biggest number and see if they add up to what I need. If I'm looking for a sum of 13, I take 1 and 13, that's too big. Well, going down to here isn't going to help me if it's too big, because that'll make it bigger. But if I move this one up, it'll make it a little bit smaller. So 1 and 9 is 10. Oh wait, that's too small now. I need to make it bigger. Well, going further down isn't going to help me. But if I move this guy up to 3, oh look, it makes it a little bigger. So now I have 9 and 3. Well, that's 12. Well, still got to make it bigger, so I'm going to move this guy down a notch. Now I have 4 and 9. Oh, and that equals 13. So if I start with a sorted list, then I can just put like my counters at the beginning and the end and just slowly move towards the middle. If you think about our first option, right, our first algorithm, we potentially had to go through every item for every other item, right? That's exponential, right? If it's a really long list, you might have to, you know, it's not quite squared, but it's pretty close, right? For every item, you have to check every item. So that's a lot. Here, we only ever have to check each item once. Eventually, we'll get our answer, or we'll get to the point where there is no answer. Right? If we were looking for a sum of 6, maybe? Yeah, say we're looking for a sum of 6. 13 and 1, too big. 9 and 1, too big. 7 and 1, too big. 4 and 1, too small. 4 and 3, too big. I'm stuck. There's no other numbers to use. But I've still only checked each number once. So it's still pretty quick. So let's see if we can implement that. The catch here is that we have to sort the list. And that really is the catch, because if you have a bad sorting algorithm that takes n squared time, like if it, like bubble sort, where it checks every item against every other item every time, then you're back where you started. It's just as slow, because the time it takes to sort it plus searching it would still be worse than the way we searched it the first time. But I'm pretty confident that the Python built-in sort function is actually very fast. I'm confident that it runs better than exponential time. So I think it's going to be better than this. So even something that is a lot better than exponential plus going through each number one at a time will still be better than what we have right now. So we're just going to take the num list and use Python's built-in sort function. So imagine your number list was 1,000,000 numbers long instead of just 10 or 100, right? So our original algorithm goes through 1,000,000 numbers, and then for each of those, it goes through, on average, 500,000 numbers, right? So that is still 500 billion comparisons, right? For each one of the million, we do 500,000 comparisons. So what I'm arguing with this new algorithm is that this sort, we're going to rely on the fact that it's going to be more efficient than this, right? And even though our new algorithm will do that comparison 1,000,000 times, it's still better than 500 billion times. So it's still going to be a lot faster. So again, we're going to start from the left, or the lowest number. So I is going to be 0. The highest one we're going to check is the length of numList minus 1, because of course you start with 0, 0, 1, 2, 3, 4, 5. So even though there's 6 elements, we're starting at the right or the bottom of the list, the end of the list, and the length minus 1. And then as long as the left end is less than the right end, so as long as we still have numbers to try, we can see if they add up to 2020. If I equals j, then the bounds, the left and the right, have come together in the middle, and then we've checked all the numbers and there is no solution. So as long as where we start, the number on the left we're comparing and the number on the right we're comparing haven't crossed over, then we still have more to check. We still have hope. So we're going to say this basically, this is the same. If the number list at position I plus the number list at position J equals 2020, we're done. Okay, we print out that number list. And we can actually break out of our loop there. Else, if the number list plus the number list of the left plus number list of the I is less than 2020, right? So if those two numbers are too small, remember, we know we can move the number at the left one more down the list. So I plus equals 1. And if the numbers are not equal and the numbers are not less than 2020, then they must be bigger than 2020. So we know that we can just subtract 1 from J. So what this is saying, as long as the position of the smaller number is less than the position of the bigger number, if the numbers add up to 2020, we're done. Else, if the numbers are too small, move the position of the smaller number up, make the sum bigger. Otherwise, the sum must be too big, so move the position of the bigger number a little bit to the left, make the sum smaller. All right, so let's see if we get the same number. And we do. So those are two different ways to solve the same problem. The second one will be much faster as the list gets longer. For small numbers, you know, in the hundreds, whatever, it'll be pretty much the same. But if you were sorting millions of numbers, you definitely want to think about being more efficient. So hopefully this was helpful and got you started on the advent of code. If you have any questions, please send me a message on Discord or send me an email. And see you next time.